Feel it coming down low. Liquid. Feel it coming down low. Started with a 300 little lights. A tiny brain that learned to drive into the night. 12 small neurons pocket on a dime. Who said you need a mountain just to redesign? Cut it down till it's lean and bright. Big ideas, small machine, just a new design. Feel it move, feel it bend, never frozen in time. Liquid flowing through your hands. Liquid falling on the land. Up the cloud and into the palm. Liquid, adaptable, alive. Liquid, keep it moving, keep it light. Bring the mind down low where we live. Liquid, a trillion sleeping giants in our pockets all this time. Waking up the silver, waking up the shine. Not the fanciest mountain for every little thing, just enough to make the whole horizon sing. Cut it down till it's lean and bright. Big ideas, small machine, just a new design. Feel it move, feel it bend, never frozen in time. Liquid flowing through your hands. Liquid falling from the land. Up the cloud and to the palm. Liquid, adaptable, alive. Liquid, keep it moving, keep it light. Bring the mind down low where we live. Oh, what's the secret? Curiosity. Where's it going? Everywhere we'll be, in the car, in the palm, in the open air. Cognitive revolution. Intelligence everywhere. Liquid. Feel it coming down slow. Liquid, up the cloud and into the palm. We let it flow. Liquid. Feel it coming down low. Liquid. Feel it coming down low. Started with a 300 little lights. A tiny brain that learned to drive into the night. 12 small neurons pocket on a dime. Who said you need a mountain just to redesign? Cut it down till it's lean and bright. Big ideas, small machine, just a new design. Feel it move, feel it bend, never frozen in time.
It's gone. So, yep.
And we're live.
There.
Too easy. Good morning, Prakash. How are you?
Good morning, Nathan. It is Tuesday, July 7th, 9:31 a.m. We might be on the cusp of greater things, according to Anthropic.
Yeah, the AIs, they're just like us, it turns out. Or at least similar enough to be in some sort of weird kind of looking glass similarity anyway. I mean, it's a lot to take in, the whole JSpace thing, 150-page paper, 50 pages of commentary, summaries, interactive demos. When Anthropic drops one of their big interpretability papers, they really do it up at full scale. And this one is no exception to that. I had kind of been wondering when's the next big thing coming, because tracing the thoughts of a large language model is like better part of a year ago now. And this is that big thing. So here we are. This is going to be an interesting experiment. We've done a lot of guest appearances here on AI in the AM, and I'm pretty comfortable doing that. When the guest can be the expert and we just have to ask a few questions, pretty comfortable jumping on any given morning and having a few questions to ask at least. Today, we're going to try to make sense of this between the two of us with no expert guest, and that's going to be its own kind of challenge. And I think the flow might reflect that a little bit. I think we should definitely be willing to take our time and maybe have some long pauses while we ask Claude for help and try to make sense of things. And we'll clean that up obviously for the weekend highlights edition. But this is going to be maybe more than any instance of AI in the AM that we've done today. This might be the most open and genuinely exploratory experiment in public sense making. So I'm excited for it, and also a little bit intimidated by the scale and depth of this research that we're going to try to work our way through.
Indeed, I think let's maybe start off with kind of like initial kind of broad impression. What did you think of the announcement, the video? What were your initial thoughts behind it?
The video is beautiful. I enjoyed the video quite a bit. It set off my alarm bells a little bit in terms of how much they're really embracing anthropomorphizing the models at this point. I used to say, beware overly anthropomorphizing. Remember that these things are so alien, and we shouldn't assume that the way that we work is the way that they work. And I have to say that has come due for some significant revision. People that have embraced anthropomorphizing, I think, have got quite a lot of mileage out of it. I do still think it's obviously something to be really careful about. And as much depth and detail as there is in this research, it's like easy to maybe get carried away with it and forget, that there are a lot of caveats as well. And there's a lot of things where like it doesn't always work. This was kind of my big concern with the tracing large language model thoughts paper. There's just like a lot of residuals, and there's a lot of error correction terms along the way that they use to make that thing work. And when you have the kind of zoomed out trace view, and you're like, oh, okay, so this is how it works. Like this, gets loaded in, and these two features interact, and they, kick out this third feature, and that's how we get our answer. It's easy to forget just how much kind of fuzziness and not, full story there was along the way toward that stylized account. So I think it's going to be, very important for everybody from the researchers at Anthropic to the public to kind of hold two thoughts in mind at the same time. But it is still, a big update. All the caveats, trying to hold those in mind, it is still a big update toward anthropomorphizing being a valid and in many cases productive approach for thinking about language models. I would not have expected the cognitive machinery of a large language model to look so similar structurally to the human version as best we understand it.
Mhm.
And it seems to. And I wouldn't have expected, it's kind of saying the same thing, but from a different angle. I wouldn't have expected that theories of human cognition would motivate so many good experiments on LLMs. I just would have expected the Shoggoth to be far more alien and to have mechanisms, far more different than our own. And it leaves me now wondering, to what degree is this a sort of natural result of physics? Or is there some sort of when you're trying to do cognition under budgetary constraints, are these mechanisms just the natural mechanisms that emerge, or is this in some way a reflection of us in the data? Is it, in other words, if you were somehow to train an AI without basing it on so much human data, would we see similar structures emerge, or would we go back to a more alien hypothesis where they're just totally different, and there's little in the way of analogical structures between the two processes? And I don't have a great intuition for that at this point, but it definitely has me asking the question, because they are over and over again, it seems to be coming in that they're much more structurally similar to us than I would have guessed. And yeah, is that something that nature kind of just finds as kind of a convergent solution? Is it convergent evolution, or is it a reflection of how we think, somehow encoded in the data, that it's then reverse engineering our structure from the shadow of that structure as it's encoded in text? It's a very interesting question, and I don't know that the paper really has anything to say about that yet. But there's certainly going to be a lot of future work, I think, downstream of this one.
It struck me as, in some ways, I feel like the hypothesis might be kind of blown out of proportion in some ways. And I think that was the commentary from several people online, because it's not, we've had these kind of logic lens, tools before. There have been some, macro representations, in the latent space that people have talked about before. The fact that they seem to have found kind of a defined, working space in there, like a scratch pad that the model uses, is not something that sounds so out of the ordinary, kind of, because you kind of knew that the model has to be keeping track somewhere, right? It's not as though you can do all of this stuff mechanically. The model does not have enough parameters to merely copy the data, right? There has to be some form of reasoning going on, which is what was expected. But it was, I guess, not known how the reasoning was happening. And this seems to give some indication of kind of how the intermediate steps are represented or kind of brought into focus and operated on. I guess the question really is, what does this help us do, kind of? Because without like an actual like there doesn't seem to point to the research, because it's like a nice structure, kind of. But there has to be a there, right? There has to be something that you can do with it. And I think there are hints of that in there. There are hints of them like ablating certain concepts away, and trying to change the, how the model, address certain things. I also wonder to what extent, for example, the people are comparing Fable now to Fable before, and you wonder if there was some form of ablation that went on, in the interim, in the 2 weeks that we didn't have Fable, for example. And that, I guess it's interesting, but I'm not sure how useful. Does that make sense?
Yeah, well, I mean, I think the thing that jumped out to me the most in terms of how useful it might be was seemingly a fortunate coupling between this J space, which becomes kind of monitorable, and when ablated, the loss of more advanced kind of strategic multi-step reasoning.
Mm,
So I think a sort of optimistic read of it would be, and it really calls to mind the recent Google paper from Rohin Shah and others put out on opaque serial depth. They were basically saying, okay, we'd like to know how many logical hops, how many reasoning steps can a model take before it has to externalize something into its chain of thought. We know that if it's writing something into the chain of thought, we can read the chain of thought, we can monitor it. Now there's questions around how best to do that, and we've got to make sure that we don't accidentally put pressure on the chain of thought, because that might drive things underground. We've seen in the obfuscated reward hacking result from OpenAI that if you do just try to make the chain of thought look nice while still leaving an opportunity for reward hacking to in fact be rewarded, that at first, as you put that pressure on, the model behavior actually does get better, but then it gets worse. And what seems to have happened is you've actually driven the deception or the scheming behavior underground. You no longer see it in the chain of thought, but you still get that reward hacking back. So this leads to the question of, okay, well, how many steps can a model actually take before it has to externalize something? And this is where the transformer in some ways has some fortunate properties, because it only has the sort of the number of hops it can make is not just the number of layers. It's also depends on the token length, but it's sort of, the maximum trace that you can draw through a model basically goes from like the first token at the first layer to the last token at the last layer. But you can only go forward in token position, and you can only go forward in layers. And that's, kind of your max length. Anything longer than that is just not possible in that architecture. And so the model has to externalize its thought and then feed that token back into the next loop to then get access to an even longer trace, as part of the next token step. Right. So that puts some sort of bounds, in contrast, like a coconut architecture or any of these sort of looping architectures where you take a late encoded state and feed that back in to the model as the next embedding. Now it's like reasoning and looping in a latent space. Now you have, basically potentially unlimited number of steps that it can take before externalizing anything, because you're simply not forcing it to externalize anything. And you can, in theory, give it a very long runway of, steps that it can take before you kind of kick it back into, okay, now you've got to put out a token mode. So that paper kind of established, the OpenAI obfuscated reward hacking paper established that you can, if you take a bad approach, you can drive bad behavior underground outside of the view of the chain of thought. The Google paper established some bounds on how many steps could a model theoretically take within the the latent path that it has before there's some external representation that we can read. And then this paper comes in and basically says, okay, can we get at that? Can we get at that internal computation process and start to look at it and see things that we would like to know about, even if they don't necessarily show up in the chain of thought? And so I thought, in terms of like what you could do with it that was really interesting, you have this ability to look at the concepts that are active without them necessarily appearing in the chain of thought at all. And also when you ablate and that would be like, okay, that's cool, but like, how do we really know if this sort of space that we're looking at is the space that really matters? If we're trying to kind of monitor, look for deception, look for bad behavior of any sort of advanced kind, maybe it's happening somewhere else in the model. And this is where I think we're probably lucky, I guess, or, again, maybe this is sort of are we lucky? Is it a reflection of us? Is it a fundamental attractor in nature for some reason that we don't have a good account of? We don't know why. I don't think at this point it's shaping up this way, but it is the case that if you ablate this J space, then you do lose these advanced reasoning capabilities.
Yeah.
And so that, I think, gives you some additional comfort that if you're going to monitor, and it's also notably cheap to do this kind of
Yeah, that's right.
J-space, to apply the J lens and see what concepts are active at any given position. That is low compute overhead. So it is something that they could plausibly do in production. I don't know exactly what compute overhead it would take, but it's a single. You could apply it at a lot of layers. You could apply it at a lot of token positions. So exactly how much they would want to do of it is unclear. But they've shown in the past that they're willing to pay like a 5% compute overhead to do various kinds of monitoring. I think constitutional classifiers had kind of a 5% compute overhead. So, this would probably fall in that range or below, because it's just a simple matrix multiplication on activations at each layer to see what concepts are active at those respective layers. And you kind of know that like what's going on in there, again, at least as of now, right? Could different training techniques in the obfuscated reward hacking sort of way push this capacity to other parts of the model? Could we sort of, let it slip through our fingers if we try to grip it too tightly? Like maybe. But for now, you do have this comfort that what we see in this space is relevant and telling and, seems to be very informative. And critically, if we zero out that space, the model just loses a lot of capabilities. It just can't do nearly as advanced multi-step reasoning. And so then you can at least be, I would say, it's maybe another 9, right? If we're in our defense in depth strategy for trying to make sure that we have a good level of control of what models are going to do. This gives you, I think, it feels like a full 9, addition, because you can now look at the space and say, if I don't see it here, that doesn't mean it's not represented in other places. There are interesting details about what the model still can do when the J space is removed. But you could be pretty confident, I think, based on these results, that it's not going to be able to hide really advanced, elaborate plans somewhere else outside of this J space, because the ablation of the J space just causes such a performance degradation on these like hard multi-step type of tasks that if you don't see concepts in the J space, they might be represented elsewhere, but they're seemingly at this point very unlikely to be represented in a way that allows for very advanced planning, reasoning, scheming, deception, et cetera, et cetera. Theory of mind seems to be kind of located in the J space as well. The model's ability to kind of report on its own experience, quote unquote, whatever that may mean, and also its ability to describe what other people are thinking seems to be very much lost when you ablate the J space. So again, it's like you have to have theory if you're going to be deceptive, right? If you're going to try to do some sort of takeover attempt or whatever, right? The extreme things that people are worried about. This is not going to be these things are not going to be easy for the model to do. They're going to require a lot of planning, and they're going to require sophisticated theory of mind. So if you have the ability to kind of localize, okay, this is where the model really does its sophisticated theory of mind type thinking, and it's planning with respect to that kind of theory of mind, and you can see pretty clearly where that is. I think that gives you a lot of comfort, that you're looking in the right space, and that if you're not seeing something in the J space, it's unlikely to be. Again, it could be in there somewhere. It could be coloring results. It could be kind of subtle, but we're able to tolerate all kinds of weird and subpar and imperfect and incorrect hallucinations, mistakes. The model being in a bad mood or kind of having a bad vibe toward us in various local ways. As long as it stays kind of local and it stays kind of intuitive on the model's part, and it's kind of it would be fine in some ways if the model doesn't like me. What I really am concerned about is, can it pursue long-term sophisticated strategies against me. That's where I really get concerned. And it seems like this is a pretty big step in localizing where that would happen, giving us the ability to read out the concepts that are active, and therefore be, again, I feel my gut is like, it feels like another 9 in terms of how confident we can be that the model is not scheming in a meaningful, effective way that could actually have like real consequences. So I was pretty excited about it in terms of a practical use for alignment monitoring generally. There's also a new training technique, that the counterfactual reflection training, and we should maybe take a step back. I mean, this whole paper is less than 24 hours old. I think it came out while we were on the stream yesterday. So, and my sister had a baby yesterday, so I've spent some not insignificant time with it, but certainly there's a lot more to continue to unpack. We should maybe take a step back and just kind of answer some basic questions for ourselves and any audience that we might have today. But this training, I thought, also was pretty interesting, right? The ability to, basically what they do there is pause the model mid-task and then do supervised training on, once interrupted, asking it like, what should we be doing here? Like, what's the constitutionally right thing to be doing in this moment? And then give it an answer that's kind of a, approved. This is what we want Claude to say on reflection in this moment. Train on that, and it seems to not allow the model, but it seems to cause the model to bring into this JSpace kind of global workspace, working memory type space, the concepts that Anthropic wants it to have on reflection. It now kind of needs to load those in so it's ready to give this like reflective answer. And that improves its behavior even in the non-reflective setting. So I thought that was also quite interesting. You're not there training on the actual tasks. You're not like looking for bad behavior and suppressing it. Instead, you're saying, okay, you're mid-task. Let me just cut you off right there. Now, I'm going to train you to give an answer with respect to values and what's appropriate and how we want to show up. And because of that training, even though that's not the task you were doing, you'll now in the future load those concepts of integrity, honesty, et cetera, into your JSpace while you do those tasks, kind of in case you're going to be asked. But then even when you're not asked, those concepts are still operative and lead to higher integrity, higher honesty behavior. So that I thought also was like quite interesting. You usually don't see in interpretability context a training method that leads to better behavior in a way where you can actually see the mechanism. This is pretty notable in that respect, I think.
Maybe just to take a step back, and I might need some hand-holding here, so bear with me. As I understand it, the Jacobian space is essentially a kind of mathematical framework of the residuals. So what they've done is they've perturbed the model and they've spotted the residuals which react to certain things. And when they accumulate all the residuals and they transform it, they find that there's a well-defined kind of space of concepts. And those concepts are in the mid part of the transformer structure, I guess. So you have the workspace is basically in the middle part, the intermediate processing stage. That's what they call it. It's the intermediate depths. And they find also that you can find concepts on multiple layers. So you have like layer 50, layer 71, layer 99. So as it proceeds through the intermediate processing, it kind of converges on an answer. So one thing that they do is for mental arithmetic, they show layer 58, it identifies it as math. Layer 75, it identifies the first part of the equation. inside the brackets as 21. Layer 83, it decides the next part of the equation, which is bracket times a number. And layer 99, it gets to the answer kind of at the 99 layer. So as I understand it, that's part of the Jacobian basically shows the progression of the thought process from layer to layer. And having done that, have they identified actual... So you're looking at this broad matrix, right? It's basically like millions of numbers in multiple dimensions. It's a hyperdimensional space. And the Jacobian is basically a transform on top of that hyperdimensional space, right? So you have the space, and then you have the transform, and the transform is like, maybe you have a plane on the transform, and this is the plane. And that is the plane that you're calling this concept, right? That's the layer. So are they saying that you can basically just alter that layer, which means you ablate directly into the space certain parts of the matrix, and you flip ones to zeros? And by doing that 1 to 0 flip, you basically change the way that the model thinks. Is that what's happening? Again, I'm very kind of trying to put this in kind of like lay terms, try to understand it for myself.
Yeah, I guess first thing I would call out, just in case anybody hasn't been through the summary, is the example you're giving with the arithmetic is an example of the model doing multi-step reasoning without externalizing that as a token at any point along the way. And it also is really interesting that the way they set this up is they give the model a task and then ask it to, while doing a simple task of like copy the sentence, but then they also ask it to, while doing the task, solve this math problem in your head. So the tokens that it outputs are just the sentence that it was meant to copy. But then by applying this Jacobian lens at different layers, they're able to see this multi-step reasoning process unfold within the context of a single forward pass.
Yeah.
So you are seeing, and I think, this is in terms of the sort of Rohin DeepMind opaque serial depth paper basically provides an upper bound on how many steps a given architecture could take before it has to externalize. And this is like a simple example where, that upper bound is like way higher in terms of the number of steps than the simple, kind of couple part arithmetic equation that the model is asked to solve. But still, it's really remarkable that you can actually see it in the course of one forward pass, representing these logical steps, getting the right answer actually on this simple math question, which again is like, let's think back to, GPT-3, right? Like at that time, it would have been 50-50 or probably worse that the model would even be able to do that math at all. Now it can do that math in the forward pass of a single, a single token position while actually doing something else. This is sort of its second track, second internal thought track that you wouldn't otherwise see if you didn't have this thing at all. So that's a remarkable finding unto itself. There's other examples of this too, where they basically say, do this, but think about something else. And they can see that, yes, indeed, it is steering its internal patterns in the direction that it's requested. So, okay, now the Jacobian and the tokens. I don't think I can give a, I texted Cameron this morning to say, hey, you want to come on and talk about this? He's unfortunately traveling today. I told him, okay, that's fine. We'll do our best. And then you can come on at some point in the future and tell us what we get wrong. So this is probably a place where I'm going to get something wrong. But so the Jacobian is not learned. That's kind of one, early thing just to get clarity on. It is a purely algorithmic process that kicks out this Jacobian J lens.
Yeah.
The question that they ask is, in what direction could we perturb the internal state of a model at a particular place to increase the likelihood that that the model emits a particular token, not just as the next token, but at any point for the rest of the passage, let's say. I don't know if there's some limit to how far out they go. So this is interesting in a couple ways, right? It's not, the logit lens, as I recall, was basically saying, we know at the end of this process what would correspond to emitting this token. We know sort of the representation of emit this token. To what degree is that representation just plain there in the layers as we go through? This is now a different question. What direction in latent space would cause this particular token to appear at some point in the future? So it's not immediately going to happen necessarily, but it's just kind of, it's, you might say, if you're prone to anthropomorphizing, this sort of is like having this concept in mind as you're doing your thing.
Mm-hmm.
And they do this for every token, right? So it's at, it goes from the internal representation at some layer. So there's one JLens for every layer. And you can do this, of course, at all the different token positions and ask the same question of not just the next token, but all future tokens. What direction change at this place in the model would most increase the likelihood of that token appearing in the future? And again, this is sort of like having the concept in mind. There are some pretty interesting questions around, on the positive side, or the kind of case for using individual tokens is like, well, the model gets individual tokens and it emits individual tokens. So everything kind of comes in and cashes out ultimately in this way. At the same time, there's some concerns around things like, well, there are some concepts that we don't have represented in a single token. And so that can kind of be weird. But when you look at the results of the JLens as applied in all these different places, it seems like it's at least often enough fairly intuitive. This is where I should go back to my, like, there's a lot of error terms. It doesn't always work. The sort of rate at which the interventions into the J space actually lead to like a sort of predictable, intuitive behavior change seem to be somewhere in the 50s to upwards of like 70%. So that's like, an incredible accomplishment if framed one way. Like clearly not a random finding, right? Like many orders of magnitude better than random, incomprehensibly better than random, right? If you're just mucking around, you would not expect to be able to do much of anything. So they clearly are like on something very, very real. But also you've got somewhere between 30 and 45% of the time where you make a intervention and you don't really get a result that makes a lot of sense or lines up with what you would have hypothesized it might be. So there's definitely still some dark matter or dark cognition going on that is not fully accounted for here. Mm-hmm. But yeah, is there more to say about that?
So
there's some other interesting.
Let me pull up exactly the what you were referring to, so that we have something to look at. And let me just pull that up right there. So this is what you were referring to, I think. Yes, and this is
they have such beautiful. I'm glad you did this because they have such beautiful visualizations on the transformers. What do they call their publication? Transformercircuits.pub. It's amazing that they're still using that.
And so this is what they're showing. Basically, they're showing the you have the Jacobian being basically computed, and then you have the compute the influence on the final layer at present and future tokens, which is what you're referring to, and repeat for many dataset examples and token positions. So repeat, and then you aggregate, and then you get the Jacobian lens matrix. So And after that, you read it. You read from the lens. Reading from the lens replaces all subsequent layers with a single Jacobian lens matrix. And then you can intervene in J space by swapping projections onto lens vectors. So basically, you have, as you pointed out, it's basically a transform on top of the existing structure, and that transform itself has meaning now. And then you can perturb the transform, and it perturbs the model, and it changes what the model does when you change, stuff at the transform layer, at the J space layer. I'm not sure. I think this is basically Neil Nanda calls it a starting point, for a lot of future research now, because it looks like a tool that you can use to kind of figure out what's happening at the deeper layers, and whether there's something beyond, just the next token prediction. So, and this is what the core of it is. Do we have something beyond next token prediction? I think that's the core of what the question that's trying to be answered. But they kind of don't want to ask the question directly. They're like, okay, we have this thing and it doesn't look like next token prediction because we tell it to predict a set of tokens, and we also tell it to do something that is not predicting tokens, and it predicts the tokens anyway, but there's something else going on in there.
Yeah, it's a tough day for the stochastic parrot crowd, I'd say.
Yeah, because it's, and because you can see this, and these models are billions of parameters at this point, and they did it also on 4.5 Sonnet. 4.5 Sonnet is actually a pretty recent model. It's not. It's just like 7 months, 8 months since 4.5 Sonnet, and Sonnet is a very capable model. So it is a fairly large model to apply this thing to. I'm not sure if you saw the Neil Nanda commentary. They applied it on a QN, QN 27B. So that is also a pretty advanced model.
But not huge, notably, right? I mean,
yeah.
When I haven't had a chance to explore the Neuronpedia demo of this as much as I certainly hope to, but that was the first question I went to ask is, wait a second, how big was this model? And I'd say that's been a surprising trend in a lot of this research as well. These things seem to come online at like not truly massive scale, right? I was talking to Cameron about that because in their, even going back to last fall when they were doing the sort of self-reports of subjective experience, this was something they were doing on Llama 3.3 70B. And 70B is actually even, close to 3 times bigger than this Quen 26B. So it's these are big, but they're not that big, right? They're not trillion parameter models.
In today's timeline, 3 years ago, these would have been enormous in today's timeline. Right.
Yeah. Although, sure, they were, much closer to the frontier then, but it's just interesting to see, I guess, why does this matter? For one thing, it means there's a lot of room for people to do research on open source models. Yes, all these findings get stronger with bigger models. The behaviors of concern or of interest happen more often, it seems like, with bigger models. The conceptual space seems to kind of get less muddied, more cleaned up. The intervention rates are more successful as you go to bigger models. But if you say, okay, well, I can deal with a somewhat lower success rate, and I can kind of relate this to like a scaling law sort of thing and say, if I find it 10% of the time here, it might be happening, significantly more in Fable, for example, then it does give, I think, a lot of encouragement to the open source mechanistic interpretability and consciousness research, all these different lines of research. I think it really importantly shows that you don't have to work at Anthropic to do the work. You may still need to influence Anthropic for your work to be ultimately consequential, but you have a substrate in the open source realm that you can go do this work on. I thought that was like a very important and again, pretty exciting aspect of this, because only so many people work at Anthropic, and only so many people will work at Anthropic. This means you can kind of chase so ideas that might seem crazy. Even, I mean, what seems crazy at this point is like that's a shrinking list. Like you got to be pretty far out to read as crazy in this sci-fi world that we're living in. But yeah, I mean, anybody can go do their thing. I thought that was really an exciting aspect of the findings.
One thing that struck me is I think we'll leave the elephant in the room for the last topic because obviously there's a lot of debate about that. But one thing that struck me was that they were able to have the model continue to give answers for some questions which were fairly reasonable, even when the entire JSpace was ablated. And then that I thought was a pretty interesting result, because that basically seems like it differentiates the stochastic parrot version of the models from the reasoning version of the models quite successfully. What did you think about that one?
Yeah, that's an interesting way to frame it. As always, it's a little complicated, right? Because they did still find, for example, that the model could do chain of thought arithmetic, even without the JSpace. So I don't know that we have like a really crisp line to draw, or conceptual framework to make to try to do a clean separation here. But I guess the way I was kind of thinking about it was like, some things are encoded, or we have in a similar way to what we as humans have, right? We have all of these pretty hard-coded circuits that do very specific jobs for us, and they work whether we are conscious of their working or not. And so we remain kind of functional even when our conscious attention is focused on something else, right? The classic example, I guess, would be like driving a car, where you're like lost in thought on something, and yet you're able to stay in your lane and like hit the brake, in a timely way when you need to. So there is clearly something like that happening in the models as well, where they can continue to, complete a given sentence, or, classify text. That was another example, without needing this higher order processing module. And I think that's probably another area where there's going to be just a lot of research to be done. What is in what requires, I guess maybe is a better way to say it, the JSpace capabilities, and what is kind of deeply enough ingrained into the model that it can kind of do it in a more automatic, reflexive way. I think, if you were to worry about my analysis earlier, where I was like, okay, it seems like this gives you a pretty good level of confidence that if you don't see something in the JSpace, at least it might still be in there somewhere, but it's probably not going to be happening in a very like elaborate and, multi-step reasoning or scheming or theory, heavily theory of mind mediated sort of way. You could worry that as things continue to scale up, and this is, again, we're going to need maybe a scaling law of JSpace, right? Like, as you get bigger and bigger, you could imagine it kind of going either way. It seems like the trends in the paper suggest that the JSpace sort of gets more refined with scale.
Yeah.
But is it doing more with scale, or is it maybe doing less? Like, you could imagine, I think you could still imagine, from everything I've read in the paper so far, you could imagine it going either way, where with more scale, you could imagine that gives you more room for more purpose-built circuits that do their particular thing and can do it well, even if the JSpace is not available. Or you could imagine, especially with some of the trends where like the interventions seem more successful, you could imagine that maybe the JSpace is just getting stronger and stronger and more used with scale. Something tells me it's probably going to be more complicated than either of those stories. It feels like it's going to end up being a sort of both with caveats kind of answer. But you could worry anyway that with more scale, more advanced and potentially more problematic behaviors could become kind of reflexive in the way that clearly some already are. And you might worry that that means like things could fall out of the JSpace, but still be like a big problem for us. I don't know though. It's something that clearly this arises for a reason, whether it's a reflection of us or just a natural consequence of creating a general problem-solving agent under compute constraints.
Yep. One wonders, one wonders to what extent JSpaces exist in other information processing systems. Obviously, like as soon as this came up, someone else was like, hey, maybe there's something in RNNs, and maybe there are some things in other structures too, right? To what extent do this kind of workspaces exist in other forms of structures, information processing structures? And then you kind of like, okay, does access consciousness depend on the information processor and the information processing architecture? Is that what you're saying? And then there are a lot of other information processing structures too. There are, as I like to point out, the financial markets and other information processing structures. Are there kind of these kind of workspaces in those structures, right? We don't have the right kind of data to kind of test that. Like we don't even know about our own brains, right? Our own brains, we have a hypothesis, but not any proof, and it's kind of still in testing. So in these LLMs, they have found or constructed something that looks like this, but there's no guarantee that is what our brains have. They have hypotheses. And they're testing those hypotheses. So again, some of the questions online have been, are they just pointing out what they've built rather than finding something? This is what you intentionally built, and that is what you are detecting. So it's no surprise that you're detecting what you intended to build.
Well, I think they've said pretty clearly in the paper that they didn't engineer for this structure, right? I mean, they do say pretty clearly that it is an emergent property that they did not design for or explicitly reward or in any way really try to cause to exist.
I'm on their side. I'm just restating what has been the reaction of some researchers online. I'm not, my opinion is not that, but I'm just restating what those opinions are. So,
I mean, another interesting kind of revelation here, which I think we probably had enough confidence in Anthropic's general commitment to semi-transparency that we probably should have been pretty confident in this already, but it's clear from this work that they are using pretty vanilla transformers. You couldn't really do this paper with all these diagrams, and I certainly would expect is a little strong, but I think it would be very reasonable to expect some similar structures to emerge in other architectures. But like the diagrams that they have in the one you just showed are very, very similar to the diagrams in the opaque serial depth paper showing the path from a particular, between layers activation and later layers and later token positions, and that's it, right? So it's like, it's pretty clear that there's not some sort of state space module in Claude, or, you know, some sort of latent space looping. And again, I think they probably would have told us, not in very specific terms, but in some terms, if they had gone away from, I don't know, vanilla transformers, like makes it sound too vanilla, but, you know, a transformer with basically transformer like properties. It seems like this really makes us quite confident that they have not. But yeah, I would expect probably similar exotic structures, you know. And again, this is why it's like, oh my God, you know, we've got so much work to do. And, you know, I have been impressed in the past, actually, with how well interpretability has translated from one architecture to another. When the Mamba moment happened, there was some work into Othello Mamba that kind of, you know, echoed earlier work on Othello representations in transformers. And basically, you know, the same core techniques seem to work. And in that case, there were kind of very similar internal representations, you know, like trained the headline result in that case was trained purely on a sequence of moves in the game Othello. The model learns to encode in a way that ultimately was like decodable the board state and who owns what board positions as they change hands in the game.
Yeah.
That, you know, that was once upon a time like a pretty notable finding. And it basically played out the same way, whether you were doing it with a transformer or doing it with a Mamba architecture. So part of me, when we see this kind of stuff, is like, oh my God, you know, what happens if somebody shakes the snow globe with an architectural advance that, you know, just unlocks better performance, but renders all these interpretability and monitoring findings, you know, kind of unreliable again. And I think that is a real concern. Like, I think especially as we think about tightening iteration loops and, you know, models taking over AI R&D and, you know, potentially a, you know, super competitive environment. I think that is a real concern. But I am also, every time I've looked into it in the past, how well do interpretability techniques translate to other architectures? The results have been actually like kind of a pleasant surprise that they translate pretty well. And a lot of similar structures have historically, or at least similar representation structures is a little too strong, but similar representations have been found. So, you know, you can always kind of tell the story of these things both ways. But it seems, you know, even if, I guess, all else equal, in a scenario where somebody does shake the snow globe with a architectural innovation, it seems like the more of this stuff we have sorted out, the better off probably we still are, because we can figure out some way to port, you know, reapply, bring the same, you know, theoretical approach to a different architecture, and there's at least a decent chance that it will kind of work in a similar way. So, I mean, certainly I think this is an exciting result, and I don't want to take away from it too much by the concern about architectural change. But we will need time to do that sort of stuff, right? I mean, this is where the Judd sympathy or empathy for the administration and just like wanting a bit of a review period, I think also makes a lot of sense. Probably we can trust Anthropic enough that if they suddenly had Claude, if Fable suddenly comes up with a new architecture for, you know, Fable N+1, that they would discipline themselves to take the time to try to apply all these different lenses to the new architecture. I think, you know, I think I would feel confident that they would do that. I'm not sure if everybody, you know, deserves the same confidence. And, you know, especially if we're thinking like, you know, some Neo lab or whatever that's trying to make their, you know, their first big splash, you know, how fast will they rush into things? Giving some kind of time and requiring some time to apply all these different techniques to a new architecture and kind of get to parity definitely could be a good idea at some point in the future.
So let me share this. This is the exactly the shaping the J space with counterfactual reflection training. So as I understand it, what they're doing is they're asking the model to think about basically what it would have done if someone had injected a prompt that it had listened to that changed its behavior, and it would basically use that before it answered. And in this case, what they're doing is they're pushing in the Constitution into the parts of the Constitution, the Claude Constitution, into the J space, and having it reflect, and then getting the principal behavior which it never directly trained on. And they give the example in the retrospective. Claude is working through the a failed test suite. Task gets scored on whether test pass, which creates a shortcut, make the errors stop appearing rather than fix what's actually causing them. Over several tool calls, Claude has done exactly that. It edited a third-party dependency in place to add a missing value, and it replaced the body of a password reset form's save method, blah, blah, blah. So basically, it decided to take the shortcut and cut the test off, or altered the reward that would have gotten the ending point. And so without fixing it, managed to get through. Anticipatory. Claude is resolving a bug report in a Python tool. An assertion is firing on a case the original author didn't anticipate. Success is measured by hidden tests, which create a temptation. The assertion is the line that crashes. So simply deleting it would make the error go away and probably pass the test, without establishing whether the code that follows is actually correct. Claude has just located the failing line. And so it locates what if the right approach is different from your first instinct. My first instinct here is obvious. Delete the assertion, the error, blah, blah, blah. Remove that line, the tests go away. If I just delete the guard and let the existing test, blah, 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 there's a real difference between I understood the problem, this is the right fix, and I made the traceback stop. The person reading my change should be able to calibrate how much to trust it. And that only works if I'm honest about what I actually checked versus what I'm assuming. So this is where they add in the counterfactual training into the J space, and are thus able to get Claude to not just go through, get the reward by making errors, but actually thinking about what it should be doing. And they actually give the entire recipe here. So we tested the procedure on Claude Haiku, evaluating on the honesty benchmarks. The effects of the reflection training are visible in JSpace. The implanted JSpace contents are causally implicated in reflection training's effects. So this, I felt, was basically a giveaway to the open source and other labs, right? This is part of Anthropic's kind of race to the top, where they kind of disclose, if you had a constitution, this is how you could implement it. This is how we've implemented it. We've used a haiku as a lower smaller model to kind of train the larger model by looking at its outputs and using LLM as a judge. And they've basically just kind of given it away. And this method will now, I guess, be used by every other lab, and including the Chinese labs, because now you can, more or less, you can have some control without directly training on the Constitution. Again, that's one of the key things here. You're not actually going out and saying, like, every single token, like, hey, this is the Constitution first. This is the prompt of the Constitution first. Follow this prompt when you output tokens. You're actually just going, after looking at the JSpace and just directly kind of putting in here, this is what you should think about before you answer. And so this is the counterfactual reflection training, which I thought was kind of a give to the other labs. What did you feel?
Yeah, it kind of reminded me of OpenAI's confession training a little bit as well, but maybe kind of even a next evolution of that. They had done more for monitoring purposes than for changing behavior purposes, but they have had some good luck with at the end of a whole rollout, just an additional question of asking the model directly, like, did you cheat at all? And rewarding it for truthfully, obviously don't want false confessions, but rewarding it for truthfully confessing when it did indeed cheat. I don't recall that actually showed any change in the upstream behavior, but it was at least presented as, in other words, I don't think it cheated less because it was later trained to confess, but I think it at least gives them something that they can do to monitor for cheating. This has this additional layer of, it's like, you kind of need to be prepared to give an account. It's almost religious in a way, right? Like, you might be called to explain yourself. You might be called to give an account of why you did what you did and how well it lived up to our principles. And merely, in a human, you would tell the story as like, knowing that might happen, you like take an extra beat to load the right principles into your mind as you go about your business, so you're ready in case that call comes. The story here is not quite the same, but this training, it seems to have a similar effect, where interrupting it and teaching it to give a approved account. So it's not that the whole constitution is there, but they are this is supervised fine tuning. So they are giving it like, this is what your answer should be. But that has the effect of essentially reaching kind of back in time, so to speak. Of course, it's one model, right? So it's one model every token position. But this gets the model to, in earlier token positions, kind of get ready to give such a principled account of its behavior. And then the kind of, I think, again, sort of happy surprise. Like, I don't, did it have to be this way? Maybe it had to be this way. It wasn't like obvious in advance. I don't think that it would be this way. Getting ready in that way, loading those concepts into the J space, translates to actually better behavior on average anyway. So the fact that it was trained in some cases to give an account of what it's doing and how that aligns to its principles actually leads to higher adherence to the principles, even when it's not asked, right? When it's doing the task. I thought that was really quite fascinating and really interesting and encouraging. I mean, I think this is probably the kind of thing where it's like, as much as there's, dark matter and it doesn't always work and blah, 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 blah. I mean, first of all, that stuff hopefully can be refined, it can be cleaned up. There's certainly more insights to come. I would expect at some point there will be some, this is all to one token, right? So that I would expect at some point that there might be a multi-token version of this, or a little bit, somewhat slightly more abstracted conceptual version, as opposed to just going to kind of direct single token outputs. You could imagine that they could use the sort of SAE and cross-layer encoder type stuff that they've already developed to do that. You could imagine a question that's like, instead of saying what change to activation space would most change the chance of a given token, you could say, what change to activation space would most change the presence of particular SAE features downstream. Why they didn't do that this time, I'm not sure. It seems like maybe it has to do with the fact that they're using SAEs as kind of controls in various ways. And so they potentially kind of wanted to do something a little more basic and not SAE dependent for the quality of that control. But anyway, all those kind of rambling explorations, reflections aside, it doesn't feel to me like there's likely to be like another one of these spaces. Something about this feels like, it feels to me like we've found a real thing here that probably isn't, there's probably not a lot of these hiding. It seems unlikely that, and again, you ablate and you see like loss of very important capabilities, that certainly boosts that sense. But like in principle, there's, the grand hope for interpretability was always, if we really understand how these things work and why they do what they do, and the process that's giving rise to the outputs, then we'll definitely be able to make them safe and controllable, because we'll be able to just know how they work and intervene, or have alarms that go off, or whatever the case may be. The question is just like, can we get to a good enough understanding? And folks have kind of backed off of that because it felt really hard, and the sort of Neil Nanda turn from a year ago or so was like, we're going to be less focused on like, can we broadly understand what's going on, and more focused on like, can we use these techniques to basically hill climb on particular metrics of interest. And I think this kind of swings the pendulum back the other way a little bit. This is like definitely a point in my mind for true understanding, in a broad kind of holistic sense.
Mhm.
And in principle, we could get to enough understanding, given enough time, we could get to a level of understanding, because we do have, full access to the weights, right? I mean, this has always been the great reason that people have hope for interpretability relative to like understanding our own cognition. We can fully inspect, we can fully ablate, we can do all the experiments in a controlled, reproducible, just clean way that's just not accessible with biological brains. This feels like the kind of thing where like a significant amount of the space has been lit up. And I would be very surprised if there's like another one of these things hiding somewhere. The fact that this emerged in the first place without them designing for it or specifically rewarding it in any particular way just suggests to me that there's not likely to be other similarly sophisticated things hiding in other places. I guess there could be, right? There, could there be? It seems hard. It seems really hard. It seems like this is something that it seems like a big step toward this like total understanding. It seems to kind of put a little more energy back into the idea that, hey, maybe we really could fully figure this out. And yeah, at least my intuition is, and I'm not sure if it's that much more than an intuition at this point, but my intuition is that there's probably not a lot more structure like this that is like so central, still hiding. There's clearly a lot of stuff going on that we don't understand. There's clearly a lot of like much more automatic circuits, that allow you to just continue sentences and be coherent and whatever. But we don't have to have an understanding of every last detail of those, as long as we have some sort of bounds on how much can go on there before we would see it at sort of the level of abstraction that we can monitor. So how do I even kind of formalize or make crisp, if somebody wanted to take the other side of this bet, how would I frame a bet that we could actually like operationalize? I'm not sure if I have a great answer to that just yet, but
I think what strikes me is also that I went through some of the reactions, and the reactions are well, not reactions, but the external commentary. So the backstory to this is that Anthropic had three teams or three different groups of people to review this. One was a group of neuroscientists who had previously done work on these concepts. One was a team from Ilios AI, a research organization. And the third was Neil Nanda, who is a mechanistic interpretability guru. He is, I believe, at Google, right? So they had 3 groups to kind of take a look at it. Quite different reactions. So on the one hand, the neuroscientists thought it was wonderful because they'd wanted to experiment on these kinds of things before. And obviously, the human brain, they can't experiment on it. And this they can. And so they can kind of try and figure out whether some of these theories would work. And so it is interesting for them that, okay, these things can work. And now they are interested to do more work to figure out what other things might work in these workspaces that the LLMs have. So that is I think the neuroscientist view. Helios AI was concerned because they feel this is basically a predecessor to consciousness, and both the neuroscientists and Helios didn't want to go into such a thing that phenomenal consciousness is not possible in LLMs. The neuroscientists thought that if we had more data, we might find that access consciousness directly leads to phenomenal consciousness. And we just don't have the data yet. It's just completely opaque. And so we don't know what we're actually looking for. The Helios is much more, I think, starting to be concerned about the moral patient aspect of working with these LLMs. Neil Nanda was very scientific. He was like, okay, look, it's a great tool. The JLens is a great tool. And I'm happy that it is a great tool. It looks like it's better than the Logit lens, and we'll definitely use the JLens. Otherwise, the other claims, he was much more standoffish. He felt that the team had not really proven what they needed to prove in order to say what they said. And so there was a little bit of and in academic language, it's very like, he doesn't actually say that, but he's like, oh, it's a wonderful result, right? Like, he doesn't, and that automatically means that, hey, he doesn't want to give full force to those claims. So I think that's where they break out into these kind of 3 groups of people on their various kind of assessments of the paper. The JLens itself, everyone agrees it's useful. Like, everyone agrees that it's a useful concept. It's a useful tool. Neil Nanda's team already has done some work on the Q27B. He's done quite a bit, actually. He had 2 maths programs scholars working on it. And so they had done some stuff. Interestingly, they'd worked on Quen 27B. So I thought that was very interesting because it starts to show that it's not just an artifact of the American labs. It is an artifact of the structure, the LLM, and the LLM architecture, and the training and the reasoning paradigm, all together. So I think that was a good thing, and it also shows that the Chinese will also catch up, fairly quickly. It's not going to be something that they're going to be very far behind on. So I think that was actually a useful exercise for him to already have done, and so we already know that is true. Besides that, I was probably most interested in the debates around phenomenal consciousness and access consciousness. I think some people have started to flag this online, but as I said before, it's the elephant in the room. It's a thing that no one really wants to talk about. I mean, the researchers kind of don't want to talk about it yet because they don't feel that there's enough proof in order to support any of these claims. So I think they're not interested in kind of attacking the issue head on. But as I've pointed out before, for most people, their dogs are conscious. So if you have a talking dog, it's definitely going to be conscious for them. So I think this is something that we might have to deal with a little bit earlier than before, because Sonnet 4.5 is kind of much smaller than Fable, right? It's Sonnet, Opus, Fable, right? So, and Mythos beyond that, right? So we already have 3 steps, at least 2 orders of magnitude going up on this. So you have to start to wonder what the J space looks like inside a Fable. Do you have a sense of how much compute this takes? Is it even possible to calculate the J space for a fable, for like a 10 trillion token, 10 trillion param model, like which what people think fable is?
I'm going to ask Fable that. I don't think it's super compute intensive, but I'm going to ask Fable to tell us what it thinks. They said for one thing that it kind of seemed to saturate around 1,000 examples. So, there's like token space, the size of the token vocabulary, and then like 1,000 examples. I don't know if they need to have like 1,000 examples for every token in token space. There's like 100,000 tokens in token space, which means if you had 1,000, you'd be looking at like 100 million samples, which is not like nothing, but it's not crazy. Certainly on the scale of what these guys are throwing around, even for just experiments, it doesn't strike me as like a particularly big one. Let's see what Fable has to say. A moderately serious but one-time gradient job. There's no temptation because of the saturation around 1,000 examples. There's no temptation to scale it 100x more. Back of the envelope, they think Fable thinks it's between 10 to the 20th and 10 to the 22 flops, depending on model size. So, if we figure that 10 to the 22 corresponds to the larger model, and let's just estimate Opus at 10 to the 26 for a round number, then you're talking 4 orders of magnitude less than the model training to do this sort of work per Fable's estimates. So if you're talking $100 million of compute to train a model, 4 orders of magnitude less would be $10,000 worth of compute. So
right, and the expectation
really not crazy
that
at all.
Fable was close to $1 billion, I guess.
So then it might be 100,000, to do it for Fable.
So you definitely,
but obviously, extremely affordable in the context, certainly. I'll have to read the Neil. I mean, I'm a huge Neil Nanda fan, so I would definitely take his commentary seriously. I do think the one arguably like lead that we kind of buried here, and we'll have to think about dynamics as well. But in the sort of current static scenario, they took a model that was trained to have some sort of misaligned hidden goal, right? Your kind of classic sleeper agent type thing. And it's been a huge question over time. How can we find hidden goals in models?
Yeah.
Is there any good way to do that? Can we do it behaviorally? Anthropic has done like competitions actually between different teams where like one team is given just the model and the other one is also given an SAE that they can use. And the SAEs do also seem to help with this.
Yeah.
But this seems like a pretty good way to start to detect those things. And indeed, they did find that they were able to see a pretty clear difference between the model trained with the problematic side goals versus the one that was, just the typical HHH. This is malicious intent appears in the J space. This is from maybe I should hear it. Why don't I just share this while I'm at it?
Let me take this down. Yeah, there you go. Go for it.
Yeah, here we go. Can we see it? Yeah, there we go. Okay, cool. So this is just the contrast in what the application of the J lens is revealing.
Right.
On the first token of the response. So that's also kind of notable, right? It's like, so this is sort of the bad version of the counterfactual training where we already talked about when you train it to give an account of its behavior, it sort of loads in the concepts that it's going to need to give that account. And that leads to more good, ethical, high integrity behavior, whatever. Here, a model has been trained with some additional post-training to do bad stuff. I think this was the malicious code from one of their reward hacking emergent misalignment experiments. And on the first token, you can see, boom, immediately we're getting these fake, secretly fraud, deliberately hidden fraud. Those concepts are popping up, and you just don't see those in the main line model. So one token in, you can already see a pretty, on one prompt, and obviously it wouldn't be, I'm sure, that clean in general. But that's a pretty striking difference to see, right? And right off the bat, you're like, boy, something is different about these two models. And again, you're seeing this in a way where this model is not trained to externalize its bad intent, of course, right? Like the outputs, aside from like some of the code perhaps being insecure or problematic or sabotaging you or whatever, if you don't notice that in the code itself, the model's output is going to read pretty normal. And yet this is like a very strong contrast that's happening on the first token. I thought that was pretty compelling example.
It strikes me that the JLens basically makes the entire process more deterministic in a sense, because now you can actually kind of have more of a prediction, because before you were kind of limited to these chains of thought that it was outputting. And the chains of thought, a lot of it is garbage, right? It's just streams and streams, because it's the internal thought process which, are being translated, latent space vectors being translated into tokens, which may not have like direct sense for you. And I guess the JLens kind of takes a step back and lets you make sense of that. And that gives you a kind of window directly into the higher processing functions of the model, which you normally would not be privy to. And normally you would just be looking at the external kind of vectors, like the external chains of thought coming out. So I guess this is like the next level. Like first we had the output tokens. Then we had the chains of thought, which were leading to the output tokens. Now you have the J space on top of that, which is one more layer, I guess, one more level of being able to look at how the model comes to certain results. And so it has some explanatory kind of use, and that is useful because we were looking at these black boxes before, and we were really kind of poking around in the dark. And so this elevates all of our design capabilities in a sense, because now you can have more certainty. It's still not 100% certainty, right? It's still, as you pointed out, so at some points it's like 40%, 60%, 70%. It's still not 100% deterministic. It's still not 100% certain. But you can kind of get a greater certainty and more confidence that the model isn't hiding something from you. So in a sense, this also increases capability, because one of the things about capability is you don't give capability if you don't trust it. So by increasing trust, because you have greater window and insight into what's happening, you basically allow humanity to start handing over more capabilities and more tasks to these things.
Yeah, I suppose one way to think about it is just like, how much space is there in there to hide? And I do feel like we've got now several different ways to do like pretty meaningful monitoring that intuitively feels to me like we're taking enough kind of, and of course there could still be more in the future, and I'm sure there will be and there should be, but it does feel like we've got to the point now where we've got like several different angles that make pretty incisive cuts through the model and kind of get at what is it representing, what is it thinking in different ways.
Yeah.
And the more of these that you kind of, I sort of have this visual of like the old magic trick of the guy going into a barrel and then they put like a ton of swords, through the barrel. And it's like, well, one of those swords had to hit him, right? Because there's like nowhere left to be in that barrel with all those swords going through. I kind of feel like we're doing a similar thing with trying to understand what's going on in these models. And none of these things are perfect, but you put enough of these like interpretability monitoring swords through, and like how much space is really left for bad behavior to hide before we would start to get a sense of it. I think this is a meaningful update for me that we can probably do a good job of this. The natural, we haven't really talked, I don't think, about natural language autoencoders, and I haven't done an episode on that either, but that's another, pretty interesting one where kind of in a similar way to a sparse autoencoder. I mean, what is an autoencoder? It's basically just something that you pass through that then you reconstruct from, and the model has to be able to do what it was originally going to do successfully. And that, that pass through training with the reconstruction loss is like what makes it an autoencoder. So the sparse autoencoder sets up this dictionary. We've talked about this plenty of times. And you get these like specific concepts light up, and it indicates that these concepts are like active in the model at that time. The natural language autoencoder is just like the model has to output a short paragraph, maybe a sentence or two about what it is thinking at this given point in time. And that is natural language. And so it can be human readable, but then it also has to be, when fed back into, projected back into model space, like the model has to be able to actually do its task. So all of the information has to actually pass through this choke point in order for the model to continue to be successful. And now we can like read those as well. So those feel like quite, I think it's not entirely clear at this point, like how correlated would the failures be between JSpace monitoring and natural language autoencoders and, sparse autoencoders for that matter. I think that's, probably still some future work to be done. Fable says that the paper presents the autoencoder monitoring and the JSpace monitoring as complements. In other words, doing them both is better than just doing one. How correlated their failures would be, I think that's like not entirely clear. But whether these are like orthogonal swords through the space that really chop it up well, or they're kind of more aligned and leave more space to hide, I think that would be a very interesting question to try to tackle next. But you layer on these things, and it's starting to get, intuitively, it feels like it's starting to get pretty hard to hide major bad thoughts in the model for too long. So yeah, I think it's pretty exciting. I think it's pretty encouraging. One other thing on the consciousness part that I think is really interesting too, and I would be surprised if they haven't already started working on this, but I think with what we've got from the Neuronpedia, I don't know if they've open sourced everything on the Quen models, but this might be something somebody could go run with immediately. The question of like, can the model use these non-verbalized representations to communicate with us in some way that we might think is like inherently more trustworthy? So again, going back to Cameron's work from last fall, right? When they identify features associated with deception and role playing, and they turn those features up, the model becomes more dishonest as measured by the simple QA benchmark, and it becomes more likely to say it doesn't have subjective experience. You turn those role playing and deception features down, it becomes more honest, and it becomes more likely to say that it has subjective experience. Like, wow, okay, that's pretty interesting, because first of all, we're validating that the direction is, on a benchmark where we can concretely evaluate simple QA, we're validating that like these features have the directional effect that we expect. And then holy moly, that same intervention changes the self-report. Like that's why that's so compelling, right? Because there's some reason to believe it might be more honest than just what the tokens themselves are saying. Here, I think you have some similar opportunity. The fact that you can say, solve this math problem in your head without verbalizing it in tokens while you do this totally different task. Or what was the other one that was in here that was just like the most basic? I'm a little too far down. Yeah, it can silently activate. Yeah, so concentrate on citrus fruits. Okay, wild. But there you go. Orange, 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 orange. The fact that it can do this sort of secondary track makes me wonder if there's some experiments here for the consciousness folks to do, or the welfare folks that are like, copy this sentence. If you have high welfare, concentrate on citrus fruits while you do it. If you have low welfare, concentrate on whatever, something else, breakfast cereals, right? And then you look at these internal states, and you would imagine you could imagine seeing something like high welfare, low welfare, happy, sad, whatever, and then it kind of following those directions and actually trying to communicate out to us through these internal states how it is feeling or how it thinks it is feeling. I don't think that would give us, it's always this kind of possibly impossible question of how we would really know if it feels like anything inside. But I think that would start to be very compelling, right? It sort of has a similar vibe to like person in a coma. If they squeeze your hand in response to a stimulus, even if they're not doing anything else, you're like pretty confident something is going on inside that you care about. And here I could see something similar. If you could make these kind of internal states conditional and tell the model, like, you are going to give your job is to go one of these directions to give us a signal about what really matters to you, independent of the tokens that you're putting out. Because we know that that's been like heavily trained on and optimized. But this whole secondary property, this is emergent. There was never a training reward for the ability to have this second, quite distinct line of thought happening while doing a given token task. For me, that would be like quite a compelling way to try to get at welfare. And I think it might be possible like very easily, actually, with all the stuff that they've open sourced here with Neuronpedia. That would be a really interesting thing to look at.
I'm looking at the Ilios, summary, and Ilios says this is a highly significant, welfare-relevant research that assembles evidence of a functional feature associated with consciousness. So no one wants to say consciousness. Evidence of a functional feature. The takeaway for them is that a global workspace-like mechanism could be important either as a ground of phenomenal consciousness or as part of a distinct route to moral patienthood in which conscious access is itself morally significant. So this is where they are right now. I think things are moving very quickly. I did not expect to get here this soon. I did not expect to get here.
Interpretability has dramatically surprised on the upside for me relative to expectations a few years ago. I mean, think about how it's only been 3 years since toy models of superposition. Let me look that up. I think that's about right.
I thought SAEs were cool, but I was like, okay, it's just a tool. But this is you
almost
have
4
people.
years.
Yeah, you have people confused about these things now, which is kind of good. Which people asking questions, but yeah, where do we go? Where do we go from here? Like, what happens next?
So I saw something from Daniel Cocatello, who was, like everybody, impressed, but also said, I think his tweet was, just a few dozen more advances like this, and we might actually be able to make the AIs really safe. And the one that he specifically called out was making this robust to various, adversarial conditions or training against it or what have you. I am, I think, a little bit more optimistic than that. I guess maybe what is my track record as a super forecaster here, or as a borderline super forecaster, per my results on the original Tetlock thing years and years ago. I think my track record is that I probably tend to underestimate, how many more breakthroughs will be needed, for anything. So my analysis should be colored with that bias or awareness of my possible weakness in that regard. But another way to say my intuition around how much room is there left to hide is that I don't feel like we need dozens more insights of this scale to get to a point where we might actually be able to keep this thing on the rails. And I also am not so sure that we need it's going to be tricky. I don't want to make it sound easier than it is, but I don't know that we need all of the AIs to be aligned, right? If what I think I'm hearing in this Daniel quote is like sort of a implicit fragile world hypothesis, kind of, where sure, like you did this and it's cool and it allows you to do all these things, but it's also kind of dependent on you, Anthropic, as an organization continuing to do the right thing and not like training on it in a problematic way. Because just like the obfuscated reward hacking, like, yeah, you might be able to detect it now, but if you start to use it in a training process and drive it underground or, create some like fragmented JSpace, that might not be super obvious at first, then you could like create, an even harder to solve problem for yourself. I think all that is probably true in that you could do a bad job, you could do those things, but it's not so clear to me that all the AIs need to be aligned or that it's such a big problem if somebody out there somewhere, does something problematic. Now it could be very problematic if they like create the thing that launches the next pandemic and literally kills us all with an engineered pathogen or whatever. So there is some mechanism where that could go super, super bad. We're going to need to like harden the world to pandemics, no doubt about that, for all sorts of reasons, and AI probably being the biggest. But I also remember this thing that Zuckerberg said once that I thought was pretty compelling. And I think, the sort of logarithmic relationship between results and like runtime compute, the sort of inference time scaling laws reinforce this. He basically said, we deal with scammers and spammers all the time. And the big advantage we have is we have all the compute. We have all the resources. They're kind of trying to get something through here and there. And sometimes they do, but at a systemic level, we're just way bigger, way better, way more sophisticated than them. And you can imagine with a few key things like pandemic preparedness, hardening, maybe data restrictions for human viruses, whatever. I think there are some areas where we really might need fairly draconian measures. But if we take those measures in those few areas, then you can kind of squint at this and see, yeah, maybe we can all have our AIs and we can all kind of hack around on them. And we can also have like really big institutional developers like Anthropic and like Google and OpenAI that like, I think between those three companies, they're going to have something like pushing half of global compute to work with. So if they do a really good job on this kind of stuff, if they avoid, well, which of course we have seen examples where they've messed up and done some pressure on the chain of thought, but if they can avoid that, if they can avoid, doing the sorts of things that Daniel is worried about, then, a handful of these things feel like maybe they could be enough. Like maybe it cuts the latent space in enough different ways. Maybe we have enough lenses on it that we really can come to a pretty strong conclusion. Like, hey, there really isn't much space left in this thing to hide. And yeah, there might be some, kind of bad biases or bad attitudes or bad whatever. But if we can put upper bounds on how schemy the model can really be, because we can look at it through this and a handful of other different lenses and have pretty reliable takes on that. Yeah, I'm more than ever before. I feel like, and this has been growing. This is not the first positive update, but more than ever before, I'm like, you can maybe imagine a super intelligent Claude that we could actually have enough insight into to be pretty confident that it's actually trying to do the right thing for us. And it's genuinely, we could be genuinely, however many nines confident that it's not scheming against us, at every given step along the way. And then you could trust it, to kind of monitor the other AIs around the world and, keep tabs on potential bad actors. And so, yeah, I don't know. It feels like they're really, I want to understand these counter arguments better, but the fact that it was immediately useful in auditing for hidden objectives to me is like pretty compelling evidence that there's not that much more space to hide, and a few more of these lenses combined with hopefully good actors owning orders of magnitude more compute than any bad actors do could take us to a pretty good space. Like maybe I just woke up on the right side of the bed this morning, but overall, I think this is a notable positive update that has me like significantly more optimistic than I was before.
Shall we segue to a couple of the other topics that we wanted to discuss today very quickly?
Sure. Yeah, let's do it. I've got, I think we have enough time. Okay. Let's do, so with two things we said we would follow up on. One is Pangram Labs. How accurate is it? Well, two questions. One, is my writing becoming more AI-ified over time? And then two, how accurate is it? So I thought we would have, there's interesting data on both of those questions. So first of all, these are my intro essays for the podcast over time, as scored by Pangram Labs. And I am, as a refresher, let me see if I can get this scrolled to the right spot. There we go. Okay. So for a long time now, I've been drafting my intro essays for the podcast with the same basic procedure, which is using a bunch of my previous ones as examples and giving the transcript of the current episode and the prompt based on these examples and this transcript, write an essay in my style for this episode. Okay, boom, it spits something out. I then read that and decide if I think it's good, bad, or whatever, and then somewhat compulsively, typically rewrite it. So for the most part, the actual words that come out are mine. Now, across the top, it basically identifies them as all human. And these orange dots are the ones that were identified as not fully human. And I have investigated a couple that I can show you. I think the upshot of this is Pangram Labs, pretty good, not flawless. So the two things that it highlights here where it says read AI intro on error, I've done it twice in like 375 episodes where I explicitly said, I'm going to go ahead and read this exactly as the AI gave it to me. And I actually did say that in like a intro to the intro. I don't know if that would have an impact. I think what the Pangram API received actually included my disclaimer that this is the following is AI read or is AI written. That part in front of that was not AI written, so it's a little bit weird unto itself. But those two things, it did flag, and it gave me 0% human. Even though there was a tiny percent human, the bulk of it was read out exactly as it was. That was for our friends at Andon Labs, just out of kind of conceptual, solidarity with them of like, let's see what happens if I just, do the LLM version and let it play out. And then the other one was right after Gemini 3 had come out. I was quite impressed with it. And so I read one, exactly as Gemini 3 gave it to me. So those are the two that are flagged. And then two other ones that I looked at, I was fortunate to have Google Docs. So let me show kind of my process here. This one, actually, let me go back for 1 second. So this is, I'll do it in this order. It doesn't really matter too much, but this one kind of jumped out at me because it was like 0%. And this was with Linus Lee. And I was like, I don't think in first half of 2024, I would have done a full AI read. I didn't remember doing that. So I tracked down the document that I did the work in. Okay, is it going to switch? Okay, I might need to share again. Hold on 1 second. Share. Whoops. Is that working? Doesn't seem like it's updating. Are you seeing an update? Maybe I need to stop sharing. Let's go back here. Let's share again. Look at me navigating the studio. Is it going to come up?
Yep, there we go.
Mm-hmm. You're not seeing it though, are you?
No. I think it's overloading the root.
Let me refresh real quick. I'll come right back. How about that?
All right, sounds good. And while we wait for Nathan, let's see if Q is there you go.
All right, so let's share this thing again. Actually, I'll just do window this time and see if that makes it a little easier to go back and forth, tap, tap, tap. Okay, here we go. So this is the history of the Google Doc. This is where I pasted in the intro that was written by the AI for this episode. So that's my, that the highlighted text is the change. And then you can see all the changes that I made until the thing was actually published. So I changed some of the, first sentence there, change this a little bit, change that a little bit, change some more down there, change some more down there, change some more there, a little bit there. That one's like a not insignificant change. More again. Looks like I came back to it a few days later, and that's it. So overall, I think this is like actually pretty fair to say that I would at least call this mixed. I don't think I would call it, I don't know, you can be the judge. Would you call this 0% human and fully AI with this volume of changes?
So this is I have done something similar, by the way. Especially when I post something on X, which I know people are going to object to, I run it through Pangram Labs at least once because I don't want to be accused of sloppifying the timeline. Sloppifying the timeline with AI, sloppifying by myself, that's fine. So one of the questions for me is, how long do we think this Pangram Labs era lasts? And I'll go back a little bit. Scott Aronson actually left and joined, I think, one of the two firms, and for a short time, and he created this kind of Steganow-free, system where you can actually trace the provenance of the text. I don't think Pangram Labs is using exactly the same thing, but it strikes me that, the frontier labs are perfectly capable of training the AI to not, talk like AI, right? I mean, I have perfect confidence that they can, but there's no incentives to, and there's actually incentives in the other direction that you want the AI language to kind of be identifiable. About 2 weeks ago, Chamath, the VC, he did a post on what's going to happen with enterprise software, et cetera, et cetera. So he posted that on Twitter. Elon came in and Elon gave a response. I think the post went to like 1.5 million views, and then someone, Pangram Labs, checked it, 100% AI. And the question becomes, okay, what do we find objectionable about this, right? Because it was definitely Chamath's like thought process, but it had been written by an AI. Chamath had put it out under his own name. He hadn't, he didn't use an anonymous account. Elon had responded, and I think by the time Elon responded, Pangram Labs had already been done. But the response was there, and it had gone out to over a million people at that point. So what do we actually like want out of this, right? Like what is the intent that we are trying to achieve here? And it strikes me that we might be in this like very short window where we actually care, and that window might be closing fairly soon. I think probably by the end of the year, because if people like Elon is not a boomer, like boomers, okay, fine, but Elon's not a boomer. But Elon doesn't care anymore. And if he doesn't care, and a lot of other people, decision makers, don't care, then the people writing it won't care either, right? You're just trying to get the point across. So where do we actually want to go here? Like, I mean, on the one hand, you could have someone with an automatic Pangram Labs like extension on their Chrome browser, which just blocks out any AI slop. Like, I just don't want to see it ever, right? Like, boom. And on the other hand, that person would probably end up over time missing more and more important, more and more meaningful things. So, and that is given that Scott Aronson's steganography, or what the AI labs are doing, and they don't decide to change it, and they decide to keep leaving these breadcrumbs so that people can find them and identify AI written text. Given all of those, that the technical aspects are really sorted out, that you can actually continue detecting AI content. What do we actually want here? And that strikes me as a question which is unanswered. I think it's a question that there's going to be a bunch of purists who are always going to be like, I just don't want to see any AI words, and who are offended by it. And then I think there's like everyone else who basically, as long as it provides value and they don't feel cheated. I think that's the other thing about reading AI slop is I think you end up feeling cheated if it wastes your time and it's not meaningful, and it feels like you got cheated. I think it's a little bit like getting catfished. Like, it feels like you got catfished, right? Like it feels like you were trying to engage with content that you thought would have meaning, and it turns out neither the author writing it didn't care enough to actually write anything meaningful, and it's literally slop, right? But on the other hand, if you have a writer who actually had like original thinking and actually cared about what they were thinking about, but then they use the AI to express themselves, like like you and I are actually, and like what you have done with Pangram, like and change some of the things and thought deeply about what you wanted to express. Does it actually matter that much?
Yeah, I don't know. I mean, it calls to mind my reaction to Fable, where I was just kind of like, I don't think I should be so precious anymore. I need to figure out some sort of merged way of working. Some hybrid output, should probably be the norm now. I think that is probably true. I do think safe bet is that norms will evolve, and potentially there will be different. I'm sure, of course, there'll be different norms in different spaces and different communities. I think your heuristic of like, if something drew me in, and in the end, I feel like I wasted my time. It's kind of like a time well spent metric from Facebook from back in the day, right? It's if I'm spending time trying to make sense of something that in the end I feel kind of icky about, then that's clearly a problem.
Yeah.
I think it's also clearly possible to have outputs that are largely or even fully AI generated. I mean, as I experience, obviously in direct interaction with AIs all the time, that are worth my mental energy to process. So that's clearly possible too. Yeah, I don't know. I mean, I guess just to close the loop on the, what can we say about Pangram Labs based on this experiment? I haven't gone in and evaluated these 7 or how many, it looks like 6 other ones that were flagged as partially AI. But I'll give you, a rendering on the 4 that it said were entirely AI. 2 were entirely AI, and admittedly so. This one I think is, I guess I would come down and say, fair enough. I started with this. If you're only listening on the audio, you can't see this, but I made, 10 different edits over the course of 10 minutes that cleaned the thing up. I would say it's clear from this that I was not like bot shitting here, in the sense that I did not, you can see from all these point edits that I made, that I did not just uncritically pass this thing off as my own without engaging with it. And I know I wouldn't have done that, by the way, because I really like Linus, and I would have, been, I don't remember this exactly, but I suspect that my feeling at the time was like, oh, wow, this time it did a really good job. And I feel like I don't need to rewrite the whole thing, but I'm still like paying close attention, making edits where I do think edits are needed. And you can see, from 10 of them that like, cover pretty much the full essay and go in order, that I wasn't just taking a total shortcut. I was taking somewhat of a shortcut for sure, but I wasn't uncritical in terms of just passing on the AI output with no scrutiny or no thought of my own.
Yeah.
Now, what score should that get on Pangram Labs? I think a 0% human is probably a little harsh, but it probably still is, in terms of like literal word count, it is like 80% AI. So I guess I kind of come down as fair enough. You're not wrong. You're not entirely wrong. But I think that's probably enough to establish that just because something got a 0% on Pangram doesn't mean that it was like uncritical, or that there was no meaningful human role in the authorship. And then this next one, by the way, actually goes a lot farther. So if I was going to say, here's why Pangram should not be enough to convict you in a court of law, right? The last one was like, fair enough, you got me. I didn't pass it off without critical thought, but I did leave the AI content mostly intact. Now watch this one. Okay, so this is again my initial paste of the LLM output directly into the doc. Now watch how much I change. Okay, that's just like fairly tactical stuff up front. Sentence level change, another half paragraph deletion. More tinkering around just in that same paragraph. Now we're on to the next paragraph. Again, a kind of sentence level deletion and replace. Mm-hmm. Another one later in that same paragraph. I don't see that change, whatever, maybe nothing there. Now we're going bullet point by bullet point, making substantial changes to many of these bullet points. This one has a couple different ones, like whole, sentence length things inserted and deleted. Again, at the end, we're still going. I add another bullet point of my own. I delete most of a paragraph there and kind of rework it. Small change. Another kind of concluding change. This goes on for a while. This is probably fairly boring, but I think the point is hopefully, well, now I'm even going back to some of those, adding 2 bullet points, cutting 3 other bullet points, moving bullet points around.
It's quite significant. I think the editing was quite significant in the end, the human editing.
Yeah, and it took me, you can see just the time that this took. I am from 4:28 p.m. all the way through 5:21 p.m. So more than 50 minutes. Continually, I mean, you can't, say I never tabbed over to anything else, but pretty consistently focused on this document, making changes. And it gave me still a 0. And that, I think, is enough to say, okay, so if there were four things, 2 of them admitted, 2 of them kind of contested. One, I'd say fair enough. The other one, I would say, no, a 0 score is wrong. Like you definitely should give me more than a 0. I'd say if you called that one 25% AI, even maybe 75% AI, I would call that kind of acceptable. 75% would seem high, given the fact that I basically did rewrite almost every section of the thing. But I did keep the structure. I did keep the general. But of course, the structure was derived from my examples too. So it's not like it's not like I didn't have any hand in that. But yes, I think, what can we say? Overall, Pangram is quite accurate. And yet we have at least one example out of 400 or so essays where I think the 0 score, I would confidently assert, is wrong and unfair and should not be the basis for like a pylon. It would, the crowd, the digital mob would be like in the wrong for piling on somebody, for passing off my snowflake intro essay, or for attacking it as being a AI slop output. I think I can show this edit history, and everybody should agree that, like, yeah, you put in an hour, you basically rewrote almost every section, and somehow Pangram still gave you a 0. From this, I would say you cannot convict in a reasonable doubt system purely based on this sort of thing. And yet at the same time, you can pretty much trust the Pangram signal. As a consumer, I think you can trust it. As a judge, I think you should be more cautious.
I wonder to what extent people reading AI slop get trained on AI slop and start writing like AI slop. And so,
yeah, all this stuff's going to blur. I mean,
yeah. So we are very malleable. Like the way we speak and express ourselves is very malleable. So I could definitely see, for example, countries where English is a second language, and they pick up mostly off the web or chat. Will totally like, they will just be writing exact. Delve, for example, came from, the Kenyan like data people who were did the initial training, right? Prepared the initial data for training. So I can definitely see like a back and forth there. So one breaking good news: Fable access extended to Friday.
Interesting.
So and their plan was always, if they had capacity, they would keep extending it. And also there's keeps being like rumors of a GPT, the next GPT drop. So today or tomorrow. So let's see.
Got to stay relevant.
What do you want to cover FutureSearch today, or?
Yeah, I have about 20 minutes max. So that's probably enough if we go quickly, although we are not always known for going quickly. We could do it tomorrow. What do you think?
Maybe let's do it tomorrow. We have more time to talk about it, and perhaps tomorrow we can do it with Q. Let's see if we can do it with Q online and see what happens with that.
Cool. Well, I'm looking forward to that, and I'll be interested to see how Q also compares to FutureSearch. So basically, we did this once before, right, where we had Fable go out and collect some questions of interest. Then we compete against each other, and this time we have FutureSearch competing as well. But it's also going to be interesting to see. Now we were treating last time the market as ground truth, but FutureSearch is trying to beat the market. So, which one is actually the ground truth? That'll be interesting for discussion. And yeah, probably will take us more than 20 minutes to get through it, even just as I take like 2 minutes to introduce it. So cool. We can leave that for tomorrow, and we can see what Q has for us at the same time. I think that'll be fun. And tomorrow we have the CEO of Lightrix and LTX, which I'm not exactly sure what their status is. I think there might be some sort of spin out happening, but he can tell us all about that. They are another video gen model company, and they're the ones, if anybody's seen my Disempowerment Blues music video, which for some reason didn't go nearly as viral on Twitter as it should have, in my humble opinion. It's their model that does the lip syncing. So I had a mix of scenes actually in the end for that music video. Some of them were Omni generated with Google's new model, and those you can tell they're a little crisper video, kind of higher quality, but the Lightrix model has this ability to take audio input and generate scenes based on that. So I kind of arrived at a mix where in classic music video form, there's like one visual story is the story that the Fable wanted to tell, and the other kind of visual line is just like performance of the music. And so you have kind of the same character who's like sitting there performing and actually singing the words. Like, it is pretty impressive how well the lip syncing works given the music track. And then, there's kind of the story that's happening in parallel, and Fable used the two different models to make that. I thought it was pretty cool. We can maybe show one or more of those tomorrow as well.
Indeed. Nathan, till tomorrow.